Welcome everyone. I'm Konstantin Hoffmann from carhs Training, and this is episode 3 of the SafetyWeek Preview. This video series features selected content on automotive safety taken from presentations that will be given at the Safety Week in September. If you want to rewatch this or previous episodes, please make sure to check our LinkedIn profile. Today we'll be talking about the new Side Impact 2.0 test from the IIHS in the United States. This challenging load case will be run with higher speeds and weight to simulate the impact of a pickup truck or SUV and the vehicle under test. Please let me introduce Becky Miller from the IIHS. As Senior Research Engineer at the Institute, she was heavily involved in the development of this new load case.
I'm Becky Miller. I'm a Senior Research Engineer at the Insurance Institute for Highway Safety. And today I'm going to be talking to you about the IIHS Side Impact 2.0 test. In 2015, we began a study to understand what kinds of side crashes remained fatal. So almost all of our vehicles receive a good rating in our existing side impact test, but we knew that people are still being seriously injured and killed in side impact crashes on US roadways. When we looked at some real-world crashes from US databases, we found out that serious and fatal injuries were happening in good rated vehicles, in vehicle-to-vehicle crashes, happening at higher speeds than our existing test, and typically with a heavier crash partner, such as an SUV or pickup. And as a reminder, in the United States, more than half of the vehicles that are on the roads are SUVs and pickups now. So, big part of our problem. Despite the pandemic, we were able to complete the research phase of the new Side Impact Crashworthiness Test 2.0 back in May of 2020. And this test features a 60 km per hour perpendicular impact. There's a 1,900 kilogram cart with suspension and the MDB 2.0 barrier face on the front of the cart. We're still rating vehicles based off of our typical scale: good, acceptable, marginal, and poor. And we're rating those vehicles based on dummy injury measures, restraints and dummy kinematics, and structural performance. So to kind of revisit the changes from the original Side Impact test to the Side Impact 2.0 test, things that are staying the same are the crash configuration, the dummies, and the components in which we are going to measure and rate. Things that are different include the test speed, an increase from 50 kilometers per hour to 60 kilometers per hour. Barrier cart structure and weight, so an increase from 1,500 kilograms to 1,900 kilograms, whole new cart structure, aluminum honeycomb barrier face, changing the structure of that, and the component and overall ratings. One of the biggest research projects that we've done with this over the last year and a half is to develop a new honeycomb barrier face. We work with Cellbond and other barrier manufacturers to come up with a design that would be more representing modern SUVs and pickups. It involves a multi-stiffness design that has stiffer areas for the frame rails and softer areas for the higher components on vehicles, like where the headlights and the grille typically are. The size and the shape of this barrier are based off of an average size SUV, which again, I mentioned, is one of the most popular vehicles in the United States on the roadways, and is also the one that we identified in our real-world crashes as being most likely to be in the crashes that cause injuries and fatalities. So this barrier is available for purchase. We have already purchased a bunch of them, and we know that other labs are also purchasing them. There's multiple locations in which you can obtain a barrier to these specifications. The other big project was to update the side cart. We were using an FMVSS 214 cart, which is not the size and the shape of an SUV. So we took this opportunity to improve upon that by building a cart from the ground up based on the size and the shape of a typical SUV in the United States. We also added suspension to it. This was not to change any kind of performance characteristics during the crash, but to provide increased stability of the cart as it goes down the runway. The vehicle weight is typically over the front and rear axles to represent the weight characteristics, the inertial characteristics of real SUVs and pickups. And we found that without that suspension, the cart was bouncing down the runway and we weren't getting accurate impact locations. So having that suspension helps it move smoothly down the runway and we're getting more accurate impacts. A technical drawing package is available on our website for this cart so that you can take these drawings and have the cart made at a facility of your own. We began our inaugural test program. So before we can create a rating system, we need to test a bunch of vehicles, a bunch of modern vehicles, to see what is actually achievable in terms of performance and to observe what kind of range we're seeing. Because small SUVs are the most popular class of vehicles currently being sold on new dealership lots, we chose small SUVs for our inaugural test program. We're testing 15 different SUVs from a variety of manufacturers and locations. We've tested 10 vehicles already, and we already see a range of performance. We'll be testing the remaining 5 vehicles over the next couple of months, and we hope to have these test results done by early summer of 2021 this year. This also means that we'll need a few months to digest all this data, look at the results, and come up with a ratings protocol. We hope to have that ratings protocol out by end of summer 2021. This means that when we come back and talk to you at the Safety Week in fall, we'll have results from these small SUVs and a ratings protocol that we can talk about in more detail. For now, you can check out all of our documents online. We have a link to everything that's available, including test protocols, the barrier cart specifications, the aluminum honeycomb specifications, and as new things become available, they will be processed and put on our website for you to look at and digest. This new Side Impact 2.0 test will be included in our top safety pick of 2023, along with a suite of other changes that are expected. So stay tuned and join us at the Safety Week for more updates on this and other test protocols. Thank you.
As Becky mentioned, this new crashworthiness test required a completely new cart for the barrier. We will be talking to Florian Meyer, the Managing Director from ERNST, who will explain the development, manufacturing, and experiences from the first applications of this new side impact cart.
Hello everybody, my name is Florian Meyer and I'm the Managing Director at ERNST. I would like to use this preview video today to tell you about the first test trials with the new IIHS crash cart from ERNST. For starters, however, I would like to briefly reintroduce the ERNST company. ERNST is located in Heidelberg and is a well-known name in the field of active and especially passive vehicle safety. Our unique selling point is the complete in-house manufacturing. This means that every product bearing the ERNST name is manufactured in-house from A to Z. This allows us to offer our customers highly consultative service and to customize our products to a very high degree so that each product is individually custom made. This strength is currently also benefiting us with the new IIHS crash cart, as we are always on site at the customer's premises during the first test runs and provide measurement support and subsequent evaluation. Fortunately, we have already received several orders for the new crash cart so that we can consolidate our measurement results now and in the upcoming month. After the IIHS published the set of drawings for the new side impact, we made it our top goal to produce the associated crash cart as soon as possible. At this point, I would like to extend my special thanks to the company ACTS in Seilauf, which, in close cooperation with us, made it possible to carry out the first IIHS test trial in Europe. We were already on site in the ACTS crash lab at the end of 2020 and were able to successfully perform all tests. ACTS ordered this crash card immediately afterwards to be able to offer the test to its customers as soon as possible. And now for the test day and the results of the first test. To perform the measurements, we used the following equipment: the Kistler Crash Designer software, the Kistler Kidau Classic, and the Kistler accelerometer shown in the picture. The entire parameterization of the test was carried out in the Kistler Crash Designer. In this process, the recording duration, general assignment, test type, and the file format were defined, among other things. These properties were transferred to the Kistler Kidau Classic and stored there. The accelerometers were positioned at the center of gravity and on the right front axle in the crash cart's direction of travel. This different positioning was chosen primarily to investigate the behavior of the newly developed crash cart suspension. ACTS provided us with a Volvo S60 built in 2005 as a test vehicle. And as you can see in the video, after aligning the test vehicle and crash cart, the IIHS crash cart was accelerated to a top speed of 60 km/h using the propulsion system and decoupled shortly before T0. After the crash, the integrated emergency braking system safely decelerated the crash cart again and the test was completed. I would like to divide the measurement results of the crash test with the new crash cart into two phases. First, I will illuminate the startup phase up to time T0. The second phase is the actual crash itself. The figures shown in the following were processed with a common CFC60 filter. So first, the startup phase. Important for us in this phase was the vibration behavior or the excitation of the crash cart caused by the crash track in the vertical direction Z. As you can see from the figures shown next to me, we measure the maximum acceleration of plus minus 0.5 g in this phase. These accelerations are transmitted directly from the running gear to the frame without any noticeable change. Based on this, we can conclude that the suspension does not have any major impact on the startup behavior. This realization is important in that we have had countless discussions in this regard in many crash labs around the world, and our customers are not in agreement. Experience has shown that the subject of suspension in crash carts always triggers discussions. Subjectively, we can say that this is not justified within the startup phase of a test trial. This means that the use of spring-loaded axles on the crash carts with suitably good tracks will not have any positive effects on the horizontal point of the impact and stability. However, very old crash labs with extremely poor floor conditions are excluded from this assessment. From the time T0, we focused our attention on the accelerations to be expected horizontally at X, at the axle beams and at the center of gravity in order to validate the structural stiffness. At the center of gravity, a maximum acceleration of 17 g was measured, whereas an acceleration of 14 g could be recorded at the front right axle. Here, a damping effect due to the springs can be noticed. Low values at the axle also occurred at this delayed substitute. Our findings from these measurement results are that the springs only develop their damping character with increased accelerations, increased forces. With the previously obtained measurement results, We at ERNST set up an FEM analysis with our design tool to identify critical points on the crash card. We eliminated these critical points by means of modifications to extend the product's service life. Among other things, a critical point occurred at the axle, as you can see in the figure. This has now been reinforced accordingly. We have also generated customized attachments on the crash card so that, for example, an outrigger rod can be attached, a sensor can be mounted at the center of gravity, or the impact shield can be adjusted for special tests. Of course, all modifications were coordinated with the IIHS so that our crash cards are still within the specified physical parameters after optimization. As you can see from these evaluations, we at ERNST do not simply rebuild products according to a set of drawings, but also invest know-how as well as time and money to optimize the product and offer our customers a tailor-made solution. So if you have any questions about our products or would like technical advice on your premises in the crash lab, we look forward to hearing from you by phone or email. And we will be happy to welcome you again at our booth at this year's Safety Week in Würzburg, where we will also present the new insights we have gained to date regarding the new side impact tests. Until then, stay healthy and look ahead even in these turbulent times. Thank you, and I look forward to meeting you at one of the upcoming events.
And this is it for today. Thank you all for watching, and make sure to tune in to our next Safety Week preview and subscribe to our LinkedIn profile.